Hey everyone, welcome to the video. Today we're going to talk about comparators, what they are, what to look for when you're picking one, and how to build a circuit around one. So let's start off talking about what is a comparator. It is a mixed signal device. It's an integrated circuit. It has a supply and a ground, and it has two inputs. You're always going to see two inputs on a comparator. It has a digital output, and that digital output goes high or low according to if the non-inverting input is higher than the inverting input, the output is high. And if the inverting input is higher than the non-inverting input, the output goes low. It really is that simple. Now there are some constraints on the inputs, namely they have to stay between the supply rails. So if you're powering your comparator from ground and 5 volts, the inputs need to stay between ground and 5 volts. There will be actually a little bit of margin that the input needs to stay in, so it may be closer to 0.5 volt and 4.5 volts. This you can find in the datasheet. It's called the input common mode range. If you violate the input common mode range, if your signals go out from in between the supply rails, you can get some unexpected behavior. The most noteworthy one is called phase reversal. The output goes to a state that is incorrect. You can get glitches in the wrong state. So if you want to get well-defined, expected normal behavior, you have to make sure that you keep those signals in check. Now the output will be high or low. It's a digital output. A comparator will always be one state or the other. A comparator won't output anything in the middle. It just doesn't. When the output is low, it's going to pull the output down close to ground. Maybe not exactly to ground, but very low. When the output is high, usually you're going to see something that is close to the supply voltage. So if you're powering your chip from 5 volts, when the output is high, you can expect the output to be close to 5 volts. And this is called the output swing. You can find this in the datasheet as well. Something else you need to know is that there's two main styles of output stage on a comparator. You can have something called open collector. With this kind of output, you need to provide a pull-up resistor or some other source of logic high voltage. And the comparator, it can only pull that voltage low. It cannot source current, but it can sink current. With open collector, you can play a trick. You can connect the output of several comparators together directly. If the output of any comparator goes low, then the output for all the outputs is effectively low. Now, in my designs, I prefer to work with push-pull comparators. What this means is that the output of the comparator does exactly what you expect. When the output is high, it actually provides a little bit of current, and when the output is low, it will pull it down to ground. There's no need for an external pull-up resistor. This means the output can be a little bit faster. Pull-up resistors tend to be kind of slow. A push-pull output gives you a nice crisp edge on the rising and the falling edge. Something else to know is that comparators tend to operate very fast. You can easily get comparators that respond in less than 1 microsecond. I would consider that really the slowest comparator that's worth using. You can find slower comparators, but they're not necessarily cheaper. And it doesn't cost that much to get a comparator that responds in less than, say, 200 nanoseconds. So comparators, they are designed to operate really fast. That's one of the things they're really good at. Alright, so that's kind of the basics out of the way. Let's say you actually want to go to the parts catalog and pick one. One of the first decisions you need to make is if you want your part to be through hole or surface mount. If you are prototyping a circuit with a solderless breadboard, you're going to need to choose a dip package. It has a 100 mil pin spacing, so it fits in those sockets. Now, that is a really big package, and if you go to surface mount, you can get stuff that's way smaller. I'd say the next extremely common option, SOIC, small outline IC package. There's also options like the MSOP, the TSSOP, the SO, and countless other packages. If you are picking a surface mount package, do pay attention to the pin spacing. The SOIC has a 50 mil pin spacing, which is still wide enough that you can solder it by hand if you have a good soldering iron. But if you get down to the MSOP, they start to get really close together, and soldering by hand takes a lot more skill. If you're getting your circuit prototyped into a PCBA, and you're just having someone else assemble your board for you, you don't have to worry so much about the pin spacing, but remember, if you rework it, you will have to solder it at some point. Another thing to keep in mind is the supply voltage range. You'll find a lot of parts can run on a range from 3 volts to 5 volts. And the reason for that is it's very common to find logic circuits that run on 3 volts, 3.3 volts, 5 volts. So a chip that can run anywhere from, say, 2.7 to 5.5 volts covers a lot of that ground. Another common supply voltage range is about 36 volts, maybe up to 40 or 45 volts. This is to accommodate old school split rail supplies. Sometimes you'll find a circuit that has plus minus 15. The reason that you'll find plus and minus supply is so that you can process signals that are close to 0 volts. When you have a single supply, it's kind of challenging to handle voltages close to 0 volts. Providing that negative supply voltage is not trivial. And if you can avoid it, I recommend you just try and avoid it and use a single supply. Here's something else to be aware of. You can get comparators that have multiple elements per package. So if you get a single element comparator, you might have a device with 5 pins. But if you add another, so you have a dual package, you only need to add 3 more pins. One last detail I'd like to mention is called hysteresis. I'm not going to talk too much about this in detail, but you should know if you have a signal that's very slow moving, sometimes this can lead to spurious glitching, where your output will go high and low several times when you only have one crossing. This can be solved with something called hysteresis. This means that the threshold will actually move a little bit based on the output. This is a quick way that you can avoid the spurious glitching when you have a slow-moving signal. So if you care about that, look for a comparator that has a little bit of internal hysteresis. And it doesn't take very much at all. Pretty much any hysteresis is enough to solve that issue. So there's some stuff you need to know about comparators and how to buy one. What does an actual comparator circuit look like? So here's an example of a circuit that will monitor the voltage on a battery and tell you if the voltage is within a certain range. So if it's over, it will output low, and if it's under a certain range, it will also output low. First thing we need to do is define a reference. I'm going to assume that we have, let's say, a 5-volt supply. We can use a resistor and a Zener diode to create a fairly stable reference. That resistor on top can be 5%, but the Zener diode, that's what's actually creating the reference voltage, so that needs to be pretty precise. This is an excellent application for an open collector comparator, or actually 2 of them, because we want to AND the outputs together so we can just directly connect them. I would recommend using a dual package for this. So let's take that reference and we'll tie it to the inputs. Notice that on one input it's tied to the inverting input, and on the other it's tied to the non-inverting input. That way one of those comparators is going to output low only when the output is under, and the other one has the opposite behavior. Then we can just take our battery voltage, send it through a couple of voltage dividers. You want to define each of these voltage dividers such that the voltage coming out of that divider will hit the reference when it passes the threshold where you want the output to go low. For these dividers, I would recommend something like 10K for the bottom value, and then whatever value works out to the threshold on top. And you're going to want to use precision resistors for those dividers. And that pull-up resistor, that can also be a 5%. And there you have it. That is a relatively simple window comparator circuit. So there's just one example of what a comparator might be used for. Now I could talk in a whole lot more detail, but I want this video to stay short, so I'm going to leave it there. Thank you for watching. I hope you found this video educational. My name is Colby. I'm a power supply designer, and I hope you come back to see the next one. Thanks a lot. Bye.